This is Math 2, 8.5 notes. That's Unit 8, Lesson 5. The title is Rational/Irrational Numbers. And we're going to go through and define those two types of numbers right now. So first one, what is a rational number? A rational number is a number that can be written as a fraction of two integers. Okay, so pretty much 1/3, 2/5, 5/2, even 3, because 3 can be written as 3/1. And it can be written as a decimal as long as the decimal ends or repeats. If the decimal goes on forever, never ending, never repeating, it is not a rational number. All right, so some quick examples of rational numbers are numbers that we're used to. 2/3, 1/3, -3/8, 5. Why is 5 irrational? Because it can be written as a fraction, 5/1. 0.5, because 0.5 can be written as 1/2. You can see the decimal ends. It doesn't go on forever with no pattern. Like if it was 0.333333, that would be fine as well. Let's write that down. If it was something like that, repeating, that would be okay as well because it goes on forever, but there's a repeat. Okay. Even square root of 36 would work because square root of 36 is equivalent to 6, which is 6/1, so it's good. A number like root 12 would not work, so I'm going to cross that one out, would not work because 12 is not a perfect squared. And because 12 is not a perfect squared, you can't simplify it like you can the root 36, therefore it's not a rational number. If you were to plug it into your calculator and get a decimal, it would go on forever, non-ending, non-repeating. Okay, irrational number is a number that cannot be written as a fraction of two integers. So when you write it as a decimal, it is non-ending and non-repeating. And non-repeating. So think of a number like pi. I'm sure you've learned back in the day that pi goes on forever and ever and ever, never ends, never repeats. Okay, so that would be an example of an irrational number. So let's write that down. Examples. We just said pi. There's such a number e. If you have a scientific calculator, you'll see the e key on there. It's right here, right above your ln key. You'll see an e to the x key. E is an irrational number as well, 2.718, blah, 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 blah. It goes on forever. Non-ending, non-repeating. All right, the ones we're going to be using in this class will be stuff like this. Root 8, root 7, the root 12 I put up there earlier, root 3, root 5. All these non-perfect squares are examples of irrational numbers. Even the cube root of 9, kids are like, oh, but 9's a perfect square. Yes, but it's not a perfect cube. 3 times 3 times 3 is not 9. Something like this, 3 plus root 5, is irrational because of the irrational piece. Even though it's being added to a rational number, if you add them together, it's going to become irrational. All right. We are going to move on to examples. We're going to simplify, then decide if the number is if it is rational or irrational. Number 1, -3/5 plus 5/8. -3/5 plus 5/8. Okay, in order to add, we need a common denominator. The common mistake kids make is they cross-reduce. We cannot cross-reduce when we're adding. If it was a multiplication, we could, but this is an addition problem. -3/5 plus 5/8, we find a common denominator. And I'm hoping you realize your common denominator is 40. We multiply here, top and bottom, by 8 to get -24. Here, top and bottom by 5 and get 25. And add, and we end up with +1 over 40. Can be written as a fraction. There's no square roots in our final answer. This is a rational number. Rational number is a number that can be written as a fraction. I'm going to put it here, P over Q, something like that. Two integers divided by each other. All right, number 2. 7√10 plus √10. We've done this before. Remember, treat them as adding variables. 7x plus 1x. There is a little 1 there that we don't see. 7√10 plus 1√10 is 8√10. 10 is not a perfect square, so it's not going to go away. It's going to stay there. So this is irrational. If you have a square root or a cube root in your, or any type of radical in your final answer that does not simplify, irrational is a type of number it's going to be. All right, number 3. First off, notice up here, because these questions will come up later, I'm adding 2 rational numbers and it's rational. I'm adding 2 irrational numbers and it's irrational. Do you think there's any way to add 2 numbers that have no square roots, 2 rational numbers? Do you think it's possible to add them and ever get it to be irrational? No, because if I'm adding 2 non-radicals, my answer is going to be a non-radical. Okay, next one. Parentheses 4 plus 7√17, close parentheses, plus parentheses 5 plus 3√17, close parentheses. And we've talked about these before, where if there's nothing to distribute, you drop the parentheses. So this gives me 4 plus 7√17 plus 5 plus 3√17, and we combine like terms. 5 plus 4 is 9, plus 7√17 plus 3√17 is 10√17. 17 is not a perfect squared. It does not simplify. That is my final answer. And my final answer has a radical in there, so it is irrational. Again, if you have a radical in your final answer and it's simplified as far as it can be, then your answer is irrational. So I was adding 2 irrationals and I got an irrational. Okay, I'm going to call this 4A. 2√5 plus 3√6. They're not like terms. That's a √5, that's a √6. Even if I were to break down and take out pairs, nothing comes out. There's nothing I can do. So your answer is the original problem. There's nothing you can do to simplify. You're adding 2 irrationals. It stayed irrational. What if, part B, I added a rational with an irrational? 5 plus √7. I can't add those together either. They're not like terms. Nothing's going to combine, so my answer is 5 plus √7. And there's a radical in my final answer, so it is irrational. So if you're adding a rational with an irrational, it is possible it can come out irrational because they're not going to combine in any way. So the radical is going to stay, and it's going to stay irrational. Okay, number 5. 3 minus 6√5, close parentheses, minus parentheses 4 plus 7√5. All right, on that one we cannot just drop because we have to distribute the negative. So I'm going to distribute. and get 3 minus 6 root 5 minus 4 minus 7 root 5. And we're going to combine like terms. 3 with the negative 4. 3 plus the negative 4 is negative 1. Negative 6 root 5 plus negative 7 root 5 is negative 13 root 5. I can't combine any further. This is my final answer. A radical of my final answer, so it is irrational. Now again, I'm adding or subtracting. They work the same way. I'm subtracting, I'm combining two irrational numbers. My answer is irrational. So far it looks like anytime I'm dealing with an irrational and adding or subtracting, it's going to be irrational. Let's continue to check. 7 plus 9 root 5 minus parentheses 4 plus 9 root 5. There is a negative to distribute. 7 plus 9 root 5 minus 4 minus 9 root 5. Do you see how the negative got distributed? 7 and negative 4 is positive 3. Positive 9 root 5 and negative 9 root 5, when you add them, they do undo each other. It's like 1x minus x. They are gone. So my final answer is 3. And that's it. And there is no radical, so this is rational. So it's possible when you're adding two irrational numbers to end up with a rational. It's a special case where these two have to be opposites, and when you're combining them, they undo each other. But it is possible. It does happen. Okay. We do have a few more to get through. 7, 8. I'm going to give these to you and have you try these on your own. And we'll do a few more to fill up this back page in class together. That is it for this lesson.